Okay, welcome back. Welcome to class 3 of ETCS5200, Artificial Intelligence and Machine Learning 1. And in class 3, we're going to talk a little bit more about intelligence and specifically intelligence traits. So today's lecture is intelligence traits. How does it know? All right, so let's go ahead and get into the material. And again, as a reminder, the links to the video presentations will show up on this slide here, down at the bottom, down in this area down here. So if you ever want to rewatch any of this, the video presentation, just go there, click on that. That'll take you through to the YouTube presentation of it. And then you can also look at the PDF version of the slides without watching the video. Okay, so now what we're going to do today is let's go ahead and just start going through material. So today's agenda, we're going to go through, well, first a silly joke, but it's a joke that has direct relevance to what we're going to be covering today. And then we're going to go through a few thought exercises about what makes something intelligent versus what makes something not intelligent. We're going to talk about intelligence traits. In other words, what commonalities are there amongst things that we tend to think of as intelligence or as intelligent. And then we're going to talk about human cognition. And then how do we test for intelligence? Come up with a generalized definition for what we would consider intelligent. Last class, we struggled to kind of pin down what we mean. We're going to try to come up with a nice definition for that. And then we're going to look at kind of key capabilities of intelligent systems as, again, circling back to that set of traits. So let's go ahead and get started. We've got some slides to get through. So let's start off with a joke. Now, this joke is set up like this. So an engineer, a physicist, a mathematician, and an AI researcher were asked to name the greatest invention of all time. And they all sit around and kind of ponder for a little bit. And the engineer speaks first, and he says, "I choose fire." And the reason he gives is, which gave humanity power over energy. And that makes sense for an engineer to pick that. He's picked something that has allowed power over the energy that we've all used and harnessed to create a lot of the modern era. And so then moving on from the engineer, the physicist chooses something a little more abstract, and he says, "I choose the scientific method, which gave humanity power over finding truth itself." So again, much more abstract, but still very astute. Without the scientific method, we don't really have a way to kind of hone in on what is true and what is superstition and what is real and what is imagined. And so they all kind of nod their heads at that one. And then they all turn to the mathematician. The mathematician says, "I choose the alphabet, which gave humanity power over symbolic thought." And so they all, again, nod their heads because without the alphabet, we really couldn't have written language. We also couldn't have mathematics with symbolic representation and formulas and all of the things that go with that kind of symbolic way of thinking where one thing really represents another. Again, great power in that. The engineer nods, the physicist nods. They all recognize, yes, that is a great answer as well. And so then there's only one left, and that's the AI researcher. And the AI researcher says, "I choose the thermos bottle." And they all just kind of stare. They stare at the AI researcher, and they're like, "What? The best invention in human history? Why a thermos bottle?" And so all of them are confused as the AI researcher sits there very confidently nodding their head in their answer. And the AI researcher says, "Because the thermos bottle keeps hot liquids hot in winter and cold liquids cold in summer. And they're like, others say, yeah, well, so what? And the AI researcher says, well, think about it. That little unassuming bottle, how does it know? It must be brilliant. It reads your mind and knows the seasons. Now, it's a silly joke, admittedly. But while the joke is silly, it does make uh, important points. And those are that sometimes things that seem complicated are actually very simple. So, yes, sure, the thermos bottle keeps hot things hot and cold things cold. But to do that, it doesn't have to read your mind. And it also keeps hot things hot in the winter, cold things cold in the summer. It doesn't have to know the seasons. Uh, the second point this makes is just like the AI researcher in this case. Sometimes we fool ourselves into seeing intelligence or intent where there really isn't any. There's just a cool, no pun intended, cold, also no pun intended, mechanical process, like a thermos bottle. Thermos bottle just has a vacuum insulating the inside materials from the outside world, and that just keeps it at whatever temperature it is, regardless of the outside temperature for a long time. And so that cold or hot inanimate things, in this case, cold inanimate things can seem magical or intelligent, but oftentimes they are neither. They're not magical, they're not intelligent, they're just unintelligent, inanimate things. And so the better question to ask here, uh, rather than how does it know, is how does the thermos bottle know, is more how do we know? So the better question is how do we know when something is intelligent and when it isn't? Because sometimes things that seem intelligent are not, and other times things that don't seem intelligent actually are. We'll talk about that later. But the better question is how can we know, or even can we know, if something is intelligent? So let's try a few thought experiments. We'll go through a few scenarios here, and we'll do some thinking about each of these one at a time and see if we can do some thinking on, can we know, or are these things, do these scenarios paint a picture of intelligence or something else? So let's start off with the first one. So I'm going to have some quotes here, and then I want you to we'll pause. I want you to ponder for a second, and then we'll discuss. So first one, if I memorize the dictionary, am I intelligent? Let's pause there for a second and think about that one. So I'm going to pause for a second. We're going to think about that one. Okay, so along the lines here, if I memorize a dictionary, am I intelligent? So what did you come up with that one? So my thought process on this is memory and learning are an important part of intelligence, certainly, but intelligence isn't just memory. It's also ability to reason and solve problems and adapt to new situations and create ideas. In other words, it involves kind of using that memory for something beyond just the recall itself. So in other words, the dictionary contains knowledge, but it's not memorizing the dictionary and the definitions is knowledge, but it's not really understanding just to memorize and repeat them. So knowing definitions doesn't mean you understand the words in context, doesn't mean you connect the ideas. It doesn't mean you can apply them in new situations. It just means you memorized a word and some other words that went with that word. So in other words, a way to look at that is having the puzzle pieces doesn't know how you put them together, how they fit together in a greater context that provides meaning. And so memorizing something, while it's useful and necessary for recall, doesn't indicate understanding. We need to go beyond that. So let's try another one. Let's try, if I can beat you at chess, am I intelligent? So let's pause and think about that one for just a second. And you can pause the video here if you'd like and kind of get your thoughts together, or chat with each other, or whatever you want to do. Chat with others around you. Okay, and this one, before I go on, this is an interesting one because this is one of those things that humanity thought chess is like this pinnacle of intelligence for humanity. It's a really challenging game for humans to play. And this is something we thought would be difficult for computers to master. Turned out to be this is a problem that's not as difficult as some simple things like uh, basic reasoning that a 2-year-old or a toddler can do. So it turns out that a big part of being good at chess is learning openings and memorizing positions, and memorizing gambits and uh, sequences and positions and patterns you've seen before. So that's not really that different from memorizing the dictionary. Although there is a sense that some stuff missing here, but let's see. Yeah, the chess also takes evaluation and strategic thinking. In addition to that memorization level, takes computation and planning, evaluation of future outcomes and choices, consideration of if I do this, then what will happen. So that's this like future planning, looking into the future. But when it comes down to it, machines can do all that through a combination of databases of prior game positions and openings and moves, and then raw computing power that just blazingly fast can look into the future at what outcomes will result from particular sets of moves. And so the end result is something we thought was really indicative of intelligence. It turns out that now no human can even come close to beating modern chess engines. 20 years ago, that wasn't the case, but now that's the case. So, for example, the best chess player alive, and arguably the best chess player who's ever lived, Magnus Carlsen, has a peak FIDE rating of 2882, which is remarkable. The best chess engines, such as Stockfish, Stockfish 17, they have ratings that exceed 3,700, 37 to 3,900 is their estimated rating. And to give you an example of exactly how good that is, a rating difference of about 240 points would indicate that you generally would not have a chance of beating that opponent. So, and these are about 1,000 points above him. So this is like 4 orders of unbeatableness magnitude above the best chess player, arguably the best chess player who's ever lived. And so that shows that unless you would say that Stockfish 17 is a superhuman intelligence and Magnus Carlsen is just a lowly human, it would be hard to argue that just because something can beat you at chess that it's what should be considered intelligent, because Stockfish can't really do anything else other than play chess really well. That's very narrowly defined for what it can do. I mean, it can't do anything else other than that. It's a program that was with algorithms. It was designed only to do that one thing. So probably not really intelligent. It does one thing well, one thing that we think of as needing intelligence, but it's not general intelligence like we talked about last time. All right, let's look at another one. If I can solve arithmetic problems in my head, am I intelligent? So in other words, if somebody gives you a math problem, arithmetic problem, they say, what's the answer? You just ponder it and you give them an answer. Does that make them intelligent? This one's probably a little more clearly cut and dried, but that certainly requires mental skill. But solving those problems just, for the most part, requires following a sequence of steps, just like when you did long division or you did longhand multiplication or even addition and subtraction with carrying and borrowing and whatnot. It does require kind of good working memory to keep track of that or visualize that as you're doing it, good attention to detail. But at the end of the day, calculators can do that. They can do it far faster and more accurately than we as humans can. And spreadsheets can compute an entire grid or entire document full of numbers faster than a human eye can even perceive the photons of light entering them and getting to your brain. So they're really good at computing arithmetic problems, but that doesn't make them intelligent. They're just a machine that's good at computing and computing arithmetic problems. All right, here's another one. If I can solve a Rubik's Cube, am I intelligent? And now this is one of those things that as a nerd and a nerd child, I enjoyed solving Rubik's Cubes and practicing and competing with my friends to see who could solve it the fastest. And there was a sense of, I did it faster than you, so I'm smart. But let's pause and think about that one for a few minutes. And if you know how to solve the Rubik's Cube, think about how you go about it. Or if maybe you know somebody who knows how to solve it, think about how they go about it and how they learned to do it. Okay, so no, it doesn't mean you're intelligent. It means you're just a nerd. Seriously, though, you may also be intelligent and a nerd, but solving the Rubik's Cube basically involves following a series of algorithmic steps, just like doing an arithmetic problem. And those steps are memorized and practiced, and you have to do a little bit of adaptation to notice which colors are where and know which part of the algorithm to apply, in what order and in what sequence. But essentially, it's more of a recognition of the state that the cube is in and then which algorithmic step to apply and then applying it and then practicing doing that faster and faster to get good at it. So again, not necessarily a sign of intelligence because there's not a lot of deduction or thought process. It's more of a, if I see this pattern, I do this thing. And then if I see this pattern, I do this thing. And that's a thing that actually they've made machines that can do this and can do it instead of in dozens of seconds or seconds, it can do it in fractions of a second, all mechanically and all algorithmically. All right, let's do another one. If I can survive alone in the wild, am I intelligent? So if I can survive in the wild alone, am I intelligent? So, in other words, you have the ability to kind of be very rugged, survive, figure things out, maybe adapt to the environment you're in. Let's pause for a few seconds and think about that one. Okay, now this one you can kind of think of it in a couple ways, but survival skill might indicate intelligence, meaning that you have to have adaptability and knowledge of how to survive and what to do. But ability to survive could also indicate like just physical prowess, like strength and speed and ruggedness for the environment that you're in, environmental suitability. And then if you think about that even further, it might not even need to have those things. It could mean that, like, for example, survival skills are something you could memorize and practice. Like you go to the Boy Scouts and here's how you build a fire. Here's how you navigate without a compass. Here's how, in other words, learning those things. It's just another form of memorization, practicing some skills. And if you think about wild animals, they don't go to Boy Scouts and have to learn that stuff. A lot of them have instincts, or they just know how to do that. They're very, very good at surviving alone in the wild. Like possums are very good at surviving in the wild. But I doubt any of us would consider them to be brilliant, genius creatures. If you've ever been around possums, they're they don't come across exactly as little Albert Einsteins when you're around them. They seem kind of dim. Um, Same thing with insects. Insects are incredibly good at surviving. Things like roaches, ants, worms. Worms aren't insects, but annelids. But all of those things are very good at surviving. We wouldn't necessarily consider them intelligent. And fungi don't even have brains. Bacteria don't have brains, but all of those are really good at survival. And they've been around. A lot of them have been around longer than humans have, a lot longer than humans have. And so, is that a kind of intelligence, survival intelligence? Maybe, but not the kind that we're usually used to thinking about, like the kind of intelligence that like some of those things can even solve problems. Like slime molds can solve mazes, things like that. But ants can solve problems with getting foraging and getting things into their nest with some problem solving skills. But we generally don't think about any of those as being particularly intellectually brilliant, even though they're good at surviving. Okay, let's do another one here. If I'm wealthy and powerful, am I intelligent? And that one, let's just pause and think about that one for just a little bit. So if I'm wealthy and powerful, am I intelligent? Speaking of unintelligent, there's Loki lying on the side, barking for no reason. Neither wealthy nor powerful nor intelligent. Loki, stop. Okay, so this one, a lot of people might say yes to this, but you might be wealthy and powerful, but that could just be because you're good at persuading people to do what you want, which could be a kind of intelligence. Or it could also be that you were born into money and privilege, and so maybe you were taught to be that. It could also be that you were taught to be ruthless, and or you could just be lucky. You could have been bought into that, or you could have won the lottery and ended up with money. You could have been bought into or been born into the right family, or while this might be an indicator of intelligence, it could also be that you are ruthless or dishonest, lack in empathy, lack in integrity, you have a high level of psychopathy. It might mean that those things are more probable than you actually have a high level of intelligence. And I'm sure we can all think of people in our society that would fall into each of those categories, people that are wealthy and powerful because they're dishonest, or because they lack integrity and empathy, or because they have kind of psychopathic tendencies that are very selfish and that worry about consolidating power and enriching themselves rather than intellectual pursuits that enlighten themselves. And so these are all things that intelligence might help you gain wealth and power, but in some cases they might get in the way of that. All right, let's do one more. If I'm able to compose and play a hit song, am I intelligent? So in other words, think of this more the creative side of intelligence. You're able to kind of think up and creatively come up with some music and compose this hit song, and you're able to play that, record it, and other people like it. Does that mean you're intelligent? So let's pause and think about that one for a second. And on this one, again, these are all, there's shades here, but this one I'd say it certainly indicates you have creative abilities, and it might mean you have a valuable set of kind of musical skills or a musical talent. And also creating a hit song might indicate you have some sort of emotional intelligence that you can come up with something that evokes feelings in people, something people can connect to, something other people like. But along with that, it could also mean that songs are based on patterns and music theory, which, just like chess openings or dictionary definitions, uh, can be memorized and combined and recombined. So, in other words, there's a lot of songs that use very similar chord progressions and very similar structures. You could just say, I'll take this and I'll change this a little bit and I'll just put some different, I'll speed up the tempo and then that'll be my new song. And so, is that necessarily intelligence or is that just memorization and recombination of something that is already in existence? And in fact, they're starting to use simple AI pattern systems to create music that way. And although this is also subjective, um, some songs that we, or at least that I hear, that are categorized as hits, uh, are hits because they're consumed by idiots with poor music taste, and they become popular not because they are of high intellectual content or even creative content, but um, they just almost like accidental, or they were like a fad. And we can all think of like one hit wonders or songs that are really not great songs. The one that comes to mind when I made the slides was "What Does the Fox Say?" or there's that Barbie Girl song. And I apologize if those are your favorite songs ever, but I will silently or not silently judge you. Um, but I guess the thing is that just like with chess, being good at music or being good at playing an instrument might take practice and dedication, and it might be an indicator of intelligence, not necessarily 100% the case. So, but if we do take that whole collection of all those like thought experiments or scenarios we went through, and we put them all together, and we look at that page. So we've got the Rubik's Cube and the chessboard and the dictionary and the wealth and power of making money and writing music and solving equations and calculating things and surviving. One of the things that I want you to think through right now is, what do all of those things that we kind of think either directly or tangentially relate to intelligence have in common? What do they all share? And so let's pause here for a second. And I want you to kind of like, maybe on a piece of paper, write down some of the things that you think all of those have in common, or at least they largely have in common. So what traits do you find amongst all those? And you'll notice that all of these things could be considered as a kind of intelligence. Like I didn't put things on here like breathing. Breathing would not be considered a intelligence, a trait that's indicative of intelligence. Or I didn't put getting hungry. That's not a trait of intelligence. Or I didn't even put something on here like walking. Okay, so take another couple minutes here. Write down maybe at least 3 traits, maybe 3 to 5. I'll give you one more minute here. It's very windy here today, so if you hear noise in the background, it sounds like a haunted house. That's what the noise is. Okay, well, let's go through and kind of talk about this. So these are all, well, first off, most of these that are up here are human activities. So, for example, animals can't solve the Rubik's Cube or play chess or memorize things in the dictionary. Animals do not care about making money. Although there are some animals that collect things and trade things. Um, like bowerbirds will collect beautiful rocks for a garden to impress their mate or whatever. Um, There are animals that make music in some ways, but not writing it and composing it the way that we do. The only one on here that's not really human centric is the survival ability. Um, but let's look at what they all kind of core human cognitive abilities. So first off, a lot of them have to do with remembering prior events and learning from the experience. So if we go back, like the Rubik's Cube, seeing this pattern in the past, I know that I need to apply this sequence of moves to undo the scrambled nature of that to get to the next set of moves I need to do. Or the chessboard, that's remembering things in the past. So remembering things in the dictionary. This word has this meaning. Same thing with music notes. Same thing with solving mathematical formulas or survival. I know that when this kind of thing happens, I need to do this. I know not to eat this kind of mushroom because that one will kill me. I've been taught that. I need to remember that. Very important to do that. Maybe the same thing with becoming rich or wealthy and powerful. I know not to invest my money in this kind of thing because in the past that was a disaster. Another one, reasoning and problem solving. So reasoning and problem solving is that ability to kind of think through this leads to this, and that will, if I want to solve this problem, I need to go through this sequence of events. And usually that reasoning and problem solving, that happens not in the physical world where you're just trying things and seeing what works. That happens kind of more in the mental space. So you look at that graphic on the left there with that light bulb above the brain. That reasoning and problem solving is more going through a sequence of things in an intellectual way or a cognitive way to solve the problem before taking action, rather than just blindly taking action. And in fact, blindly taking action is usually a sign of reduced cognitive capability. In other words, here's this problem, I'm just going to start doing things rather than thinking about it. And so notice all of these, like before you make a chess move, think about what that's going to result in. Or for survival, very important. If I'm going to survive the night, it's going to be cold. I need to start thinking through what I need to do to be prepared for that. Or even solving a math problem. What do I need to do to get to the goal of where I'm trying to get with that? Now, adapting to new contexts, that means that when the situation changes, we need to also adapt and change with it. We can't do the same thing we were doing if the situation changes. So being cognitively flexible, willing to make changes to our plan and our reasoning as the situation changes. And so you can see that here, the chessboard. The opponent makes an unexpected move. That changes our whole analysis. Now what do we do? Or survival. Suddenly there's a rainstorm. Now what do we do? Sometimes with music too. You're playing in a jazz group, and sometimes it's not all planned out, and somebody improvises, and now I'm going to adapt to that improvisation. So a lot of need to make change. Same thing for the power in business. What do we need to do? Oh, the market's changed. Somebody invented a new thing. This is no longer the top thing anymore. Now what do I do about that? And then the last couple here, planning for the future. Again, that goes along with that reasoning and problem solving, that ability to look and think through your actions now and what they will cause rather than just doing something and seeing what happens. And then along with that comes that kind of creativity, innovation, coming up with novel solutions, that almost like the more of an intangible part for the creativity and the innovation of thinking outside the box, or thinking of something that was not something that was remembered or learned from prior experiences. Or maybe it came from prior experience, but it's a new application of that prior experience that wasn't an exact replication, but a leap of a cognitive leap that came from that prior thing. Now, back to something we talked about last class, and that's the kind of narrow AI versus general AI, or weak versus strong. And that is, if we think about narrow AI, we talked about this last class, that is a kind of AI that can do specialized tasks. Like some examples that I put on here, like self-driving cars. Self-driving cars are not pondering the state of the universe, or even doing things like writing responses to chatbot prompts. They're just driving a car. They're looking at the sensor data and they're deciding what direction to steer the car and what actions to take with the car to keep the passenger safe. Image classification. You give it an image. You say, does this image have people in it or not? Or does this image have, is this a man or a woman? Or is this image a dog or a cat? And so, or if you're using it for military purposes, does this have a satellite image of military equipment, or is it just a city with normal vehicles in it? And so image classification, again, very narrow, very specialized, narrow AI task. It's not going to be able to drive a car. It's going to be able to just classify images. Or language translation. Here's this document in English, translate it to French. Or here's this document in, I don't know, let's say Dutch, show it to me in German. And so those ideas, again, that's a very narrow system that does have to know a lot of things, and know in quotes there. It has to have a lot of understanding of language and patterns. But it's still a very narrow task. It's not going to drive a language translator is not going to drive a car or classify images. It's only going to translate languages. And then speech to text is another one. You give it some speech, like I'm talking now, and you want to have closed captions generated. That's a very narrow task to turn that sound, that sequence of sounds, into the text that shows up at the bottom for the closed captions. That's, again, the speech to text system is not going to translate language or classify images or drive a car. They're all very, very narrow. Now, general AI, on the other hand, which we did talk about last class as well, that's kind of this human level adaptability across different domains. In other words, humans can drive cars. We can sort things into image piles based on classification requests that we're given. We can, if we know two languages, we can do language translation, and we can definitely turn speech into text, like you're kind of mentally doing that as I'm talking now and you're listening to me. That's more of generalized AI, rather than a very narrow slice of capability. It's more of a generalized ability to do any and or all of those things, or at least be adaptable to learn to do those things. And that's where we come up with that concept of last time we talked about AGI, artificial general intelligence. And that is where something is truly intelligent and truly understands things, rather than just this narrow little slice of being able to do one thing that we would usually classify as intelligent. And that's where we get to this concept of getting to the point of where we have things that are sentient, like a machine that actually understands that it understands, is a way to put it. And so most people think we're not there yet. Some people think that we are either close or we already are there in some way. But it's interesting, certainly interesting to ponder. Now, back to that question, how do we know? And instead of how does it know, how do we know? How do we know if something is intelligent? So let's say we've created an AI entity and we're not sure if it's actually intelligent, but we really want to know. We want a way to figure it out. So the question is, how can we test it for intelligence? And what would we do to test to see if it's intelligent? So this, again, we talked about this last time with Justice Potter Stevens, or I think that was the name, Potter Stevens, I think that's right. Potter Stewart. But anyway, we talked about it being not so easy to know or to pin down. And so this was the thing that over the years, as computers got invented and humans came to the realization, hey, we can put code in this that lets them run ideas in there. Can we make them actually intelligent? And this is where Alan Turing came up with this idea as a way to test for intelligence. And his test for intelligence, and we talked about this previously, we'll talk about it again, was what's called the Turing test. And the Turing test was you basically have your AI entity, and then you have a human, and the human chats with the AI entity. And in his test, it could be through something like a teletype, like a chat room, where you can think of it as you're just passing messages. You write something on a piece of paper, you pass it to them, they write a response on a piece of paper, give it back to you, kind of like a pen pal, but more quick than that, like a chat room. And so the Turing test concept was that essentially it's this behavior-based definition of intelligence, where his idea was if the evaluator is chatting with the entity, which they chat using natural language, using basically just as you would chat with somebody on Discord or another chat environment, like text messaging, for example. And if the evaluator cannot determine that if they are human or not human, then we consider them as passing the test. So the entity is intelligent if a human cannot tell that they are an AI. So in other words, if the AI entity can fool the human into believing that they are also human, then the AI must be intelligent, must be actually truly intelligent. Now, again, the Turing test is behavior-based. Notice Turing never cares about what's going on inside of the AI entity. It doesn't care about what its thought process is. All it cares about is, can it fool the interrogator, the evaluator? And if it can fool the evaluator, then we say it's intelligent. Now, there's some criticisms of this, obviously. And the criticisms, here, let me do that so you can see all of the sad robot there. The main criticisms of that Turing test come from the fact that it is behavior-based, that it's entirely based on the behavior. It doesn't look at what's going on inside the head. In other words, that sad robot there, we don't look at what its thought processes are in the Turing test. We just look at, did it fool us? And so the criticisms can be boiled down to this list of things here. So it only measures, first off, our only way of interacting with it, if we go back a second, is through language. We just use this natural language to communicate with it, and it chats back with us. So it's only measuring linguistic intelligence. We send it a chat message, and it sends a chat message back. Also, there's a criticism here that this relies on a human evaluator to determine whether or not they were fooled. So in other words, we're relying on the human evaluator to say, yes, it tricked me, or no, it didn't. And we don't know if that human evaluator is easily fooled, or they have a determined, or let's say a bias, confirmation bias, where they are going to either say, yeah, it seems human to me, even when it doesn't, or maybe they're used to being around people who say crazy, goofy things, and they think that crazy, goofy responses are normal. The other problems with this is it relies only on that external behavioral evaluation. We talked about that. It doesn't care at all about what's going on in the thing's head. It doesn't care if they're actual thoughts. It doesn't care what the thought process is. It doesn't care about the internal states that underpin the output. All it cares about was the evaluator fooled into believing that was a human? And the last word in that sentence, was the evaluator fooled into believing it was a human, is also important because it's only really evaluating human like intelligence. In other words, there can be other kinds of intelligence besides humans. Like, for example, it's very clear that other animals, like corvids, crows, and ravens, solve problems. They have complex social interactions with other species. Another one would be like, for example, orcas, so killer whales. Orcas have complex social hierarchies, and they communicate with each other, and they even like do things like play, and they have like fashion fads that go through their pods. Um, no orca could convince a human that they were a human on a chat room, but it's clear that there's some form of intelligence underpinning a lot of their behavior. Same thing with bonobos as primates. There's clearly an intellect of some sort there, and thoughtfulness. Orangutans as well. There's a thought process. They are looking at the world around them. They're perceiving things. They're considering them. They're making differences in how they behave based on what they perceive. And they're a lot of the hallmarks of what we talked about as having intelligence. Their behavior indicates, but they would not fool us on a chat room. They could not get on. You could not have, for example, a dolphin, a porpoise, or dolphin on like a chat environment, typing away on the keyboard, tricking us into thinking it was a human. But that doesn't mean they're not intelligent. The biggest criticism that I have of this is it values deception over any kind of measure of true understanding. In other words, this does not gauge any kind of understanding or cognitive process at all. All it says is, was this person chatting with us fooled into believing that was a person on the other end? And because it values deception, there are a lot of psychological tricks that the person who makes the system could do to, for example, if you ask about something it doesn't know about, there are ways you could code in tricks to deflect from that or to get the conversation away from that into something you do know about. And humans do that. And sometimes that's a sign of intelligence. Like, I don't want to talk about that. I want to talk about what I want to talk about. Or your argument is that you're making is making me uncomfortable. So I'm going to deflect and use a logical fallacy to get you away from that. Or I'm going to use a gish gallop and throw a whole bunch of information on you that you can't respond to. That can be a sign of intelligence, but it could also be kind of a tactic used to overwhelm or deceive the human by distracting them from the fact that we are unable to, our AI system that's trying to be deceptively human, is hurting the evaluator away from areas where it would perform poorly. Like, for example, you ask it a question about something that would require deep logical thinking. It'd be very easy to make the AI program say, this is boring. I don't want to talk about it. Let's talk about, I don't know, marsupials or something that it knows a lot about. Or let's, and if you've ever had, if any of you have kids, you might like, I don't want to talk about that. Let's talk about dinosaurs or something along those lines. Now, the main point about this is the Turing test does not look at all at anything other than language, and all it cares about is, was the evaluator deceived? Now, there are some updates that have been proposed to that to make it a little bit more robust as a test. One of them, or a few of them, are listed here. So one of them is what's called the total Turing test, and that was proposed by Stephen Harnard, or Harnad. But his update to that was, instead of just having a chat, add perception and physical motor skills to the linguistic test. In other words, think of this more like a Android robot where you have to ask it to do things and talk to it, and it has to be able to respond and do those things. So you might ask it, hey, could you, for example, move those pens from that cup on the table into that drawer? And it would have to, A, be able to look and understand what you're saying, and then act and use motor skills to then carry out that sequence of events to bring that thing to achieve the goal that you asked it to, or interact in that way. And so, in other words, this moves it away from being purely linguistic based, purely kind of just text coming in and text going out, into something that involves perception, like with senses, like we have eyes and ears. This allows us to have this thing that has to look at the physical world and interact with it. But it doesn't get us away from the human-centric part of this. Like, for example, I could take an orca and ask it to do physical things that humans could do. Like, hey, orca, do you want to play? You want to get the badminton racket and hit the birdie around? And it's going to not be able to respond and talk to us because it doesn't have vocal cords like we do, and it doesn't have hands, and it can't do that. Doesn't mean it's not intelligent. Also, this visual Turing test that involves AI interpreting or describing images or videos in a way that's indistinguishable from humans. One of the ones they'll do here is, like, for example, show it a movie clip and then ask it questions about what happened in the movie. That's one of the ones that's been proposed. So you might say, for example, here's a video of, I don't know, let's say children playing with birthday balloons and singing happy birthday or whatever. And so then you might ask it questions about what it just saw. It's like, what do you think is happening here? And if it doesn't say it's a birthday party, or it doesn't say that it's some kind of party, or if it doesn't talk about the balloons, or you can even ask it like, oh, well, what, like, did it look like they were having fun, or how do you think the kids felt? And so the idea there is to make it more of their visual elements that it has to look at and perceive. And then to perceive those, it needs to be some sort of understanding. But again, very human-centric, and also potentially achievable with statistical large amounts of data and large amounts of statistical information. In other words, if you have enough labeled pictures with kids with balloons and kids at a birthday party and doing stuff, or enough labeled videos, you might be able to have something that solves a visual Turing test in a way very similar to humans, but without actual understanding as we understand it. Now, the last one on here goes back to a linguistic test, away from the physical perception and physical actions. But this one's a little more interesting than the Turing test because it doesn't, well, there's two things interesting about it. It doesn't require the human evaluator to say whether or not they were fooled. In other words, there's a yes or no answer, or a right or a wrong answer, I should say, for each of these. But what it does is you give a couple of sentences or a sentence to the AI system, and then you basically ask it some common sense questions that are related to the reference in the sentence. In other words, you'd say, who in the sentence did this, or which party in this was the one that was sad. And it's surprisingly, even with very simple sentences, it's not as easy as it sounds like it would be. And we'll look at some examples here in just a second. But and the reason for that is because it requires some human knowledge and understanding in order to tease out who we're talking about in what contextual situation. And so the AI entity has to correctly identify the referent in that. And this is a case where it's not just fooling somebody or not. This is a case where there's a right and a wrong answer. to each of these questions. And if you give the AI entity enough of these, then a human would very easily pass this, but an AI may not, because there's a linguistic structure, but also knowledge that underpins that common sense situation that you have to be able to understand in order to get the right answer. Let's look at a couple examples of this. All right, so here's one. The university administration refused the students a permit because they feared negative publicity. Now, to most of you, that sentence probably is pretty clear. The university administration refused the students a permit. Okay, well, that makes sense. The administration did not give the students a permit. But then the second half of the sentence is where things get a little bit fuzzy, especially if you're an AI that doesn't understand the world. And it says, because they feared negative publicity. Now, there's the word they. They has two possible referents there. Is they referring to the university administration? Or is they referring to the students? So the question becomes that you ask the AI is, who feared the negative publicity? Is it the administration? Or is it the students? And so notice that on its surface, this is a really trivial question. Who feared the negative publicity? Well, it's clear that what the answer would be here. It's not the students, because why would the university not give them a permit because the students were afraid of negative publicity? That doesn't make any sense. But to know that, you have to know something about the world and what students would do with a permit, and what negative publicity means, and who would be worried about negative publicity. And so if we compare that to this other example that's closer related, the university administration refused the students a permit. All right, so that started out the same. That first part is identical. And then the second half says because they intended negative publicity. There's only one word difference in these two sentences, and that was feared switched to intended. Now the question is, who intended negative publicity? Because this shows that you can't just do a sentence diagram to figure out who the referent is for they, because now the they clearly goes with the students. The administrators did not give the students a permit because the students intended negative publicity. The students were going to do something to cause negative publicity, so the administration didn't give them the permit. The top one, the administration didn't give the students a permit because the administration was afraid of negative publicity. So you'll notice that you might think, oh, this is easy. You just diagram the sentence and you figure out which thing this goes with. It's not that easy, because you have to know things about the world to understand the context of these sentences. And the idea behind the WSC, the Winograd Schema Challenge, is that if you do a whole collection of these, a human will get, unless they're tired or lazy, will get 100% of them correct. And AI entities will potentially get a large number of them wrong, depending on how good the AI system is at deducing them. Okay, here's some other ones. The sculpture rolled off the shelf because it wasn't level. And then the question is, what wasn't level? Was it the sculpture or was it the shelf? And this is the case where a human, well, the sculpture would roll off the shelf because the shelf wasn't level. You pick shelf. But if we look at the bottom sentence, the sculpture rolled off the shelf because it wasn't anchored. Again, we only changed one sentence. And now we say, what wasn't anchored? And now it switches to the sculpture. The sculpture is the thing that rolled because it wasn't anchored. Nobody attached it to anything. So this is the kind of thing that humans do really well with, and we don't even know we're using this knowledge base of understanding when we do this. You might think, oh, we're just diagramming the sentence in our head and like, oh yeah, anchored goes with sculpture or level goes with shelf. But really there's knowledge there. What kinds of thing, you have to understand something about the world to know that if the shelf isn't level, things are going to roll off it. Or if something's not anchored, then it's more likely to fall off a shelf. All right, let's do one more here. One more set anyway. All right. I spread the cloth on the table in order to protect it. What is being protected? In this case, we as humans know we put tablecloths on tables to protect tables. You don't spread the cloth on the table generally to protect the cloth. You put a cloth in a drawer to protect it, or in a box to protect it, or I don't know, maybe inside of a suitcase or a bag or something like that. But you don't spread a cloth out on a table to protect it. You spread the cloth on the table to protect the table. Now, the bottom one, I spread the cloth on the table in order to display it. Again, notice change of just one word. But what is being displayed? Well, you wouldn't put a cloth over a table to display the table. That would cover it up. You would spread the cloth on the table to display the cloth. So again, notice there are a lot of subtleties in this. It seems like a very simple test, but there's actually a lot of subtle complexity that underlies doing this successfully that requires linguistic understanding of grammatical structure and word meanings. But not just that. We also have to understand things about the world. We have to understand common sense things about the world. Like, for example, what kinds of things of those two are more likely to be protected? Or what of those two things is more likely to be the thing that we're displaying? Nobody puts a cloth over a table to display the table that covers it up. Notice there's a sequence of thoughts that you have to go through to make sense of that. Okay, now, the WSC, the Winograd Schema Challenge, it was kind of proposed as a tougher alternative to the Turing test. And it also has the advantage of being objective in that there's a right or wrong answer to those. That doesn't require a person to just say, yep, I was tricked. You got me. Because that's, some people might be more easily fooled than others. This is the thing that you can give a list of these and say right or wrong on each one of them when it tries to find the answers. So this is presented as a way to measure genuine language understanding, both syntactically and semantically, that requires language awareness, but also common sense reasoning rather than just simple pattern matching. And that's why this is a tougher alternative to the Turing test, where the Turing test is you ask a question and it just gives a response. And in giving those responses, systems can be designed to distract you or deflect away from things that it would have a hard time with making responses for. For example, years ago, I made this AI entity named Louis. We might talk about Louis later in the semester. We will in this class, because the AI chatbot we're going to do is a version of something similar to Louis this semester. But I put Louis on a chat room online back in the day when IRC, Internet Relay Chat, was a thing. And Louis would chat with people. People would chat with Louis. They did not know Louis was an AI entity. And some people would chat with him for an hour, 45 minutes and not realize that it was a AI entity, even though it would say just like outlandishly idiotic, crazy things sometimes. They just thought it was like somebody being goofy or silly. But if you ask them at the end, it's like, was that a person? They'd probably say yes. Because a lot of times they would say something and then it would learn from talking to them. So it would say something about kind of the topic they were talking about. But then every once in a while it would just say outlandishly crazy things. And the people's response would be like, LOL, you're being silly. And then it would say back to them, LOL, you're being silly, or something like that. Or LOL, haha, you're right, or whatever. And so those people may have been fooled, but I guarantee Louis was not sentient or truly thinking or intelligent, because I know how it worked. It was just this pattern matching statistical processing game that was being played to produce somewhat plausible responses to what that were around the topics that they were chatting on. Now, the nice thing about the WSC is it's not up to a person to decide whether they were fooled. It's either right or it's wrong. and it's not just simple pattern matching. It has to be more than that. Now, there are, however, some potential issues with the WSC and the Winograd Schema Challenge. Those issues are, first off, it's susceptible to statistical exploitation, meaning that modern large language models can be trained on so much data, so much text, that in that text, there are generally sentences similar to the ones somewhere in there. If you train your LLM on everything that humanity has ever written or created, chances are there's going to be somewhere in there with something similar to one of those WSC, let's call it up, statements or problems. And that means that it could, if it has been trained on that, it could look at that and emit the right answer just because it's in the database. I shouldn't say database, the data set that it was trained on somewhere had something similar to that it then just pops out the right answer because of it was trained on something similar enough to that it got it. And so if you have a large enough training set, it's possible to pass this with a pretty high accuracy rate without any explicit reasoning module being built into it where it has to think through or understand anything. In other words, it's trained, it has a neural network, and you feed it in that thing and it predicts the next word and it says, yeah, it's this one. With enough data, you could overcome the limitations of not having reasoning by just having a massive storage of training data. The second problem with this that has arisen is because there's a limited number of sentences that can fit that, and there's the WSC has had a standardized set of these, so you could compare one AI entity to another. And the problem itself was kind of widely known and circulated. People that made AI systems kind of hard-coded their systems to be able to handle those solutions and get the right answers. In other words, they trained their system to say, hey, when this WSC query comes up, then this is the right answer to that. Let's train it to get all of the WSC things correct. So the idea is that can make them very successful at getting the right answer, but not for the right reason, not because it did any of the understanding or reasoning, just because it had the list of questions. It's like cheating on a test. If you know the questions ahead of time, it's easy to get the right answer without any true understanding. The last criticism of this that I'm going to mention is it's a binary evaluation. You're picking between one of two things. You're saying, is it the administration or is it the students? You pick one. Or you might say, if we go back to some of those, you might say, what's being protected? Is it the table or is it the cloth? Or you might say, what isn't level? Is it the sculpture or is it the shelf? It's always kind of this binary choice between one or the other. And because of that, that limits the amount of investigative pathways for choosing one, which opens the door, again, back to that statistical exploitation above. You only have to narrow it down between one or the other. And a lot of times that can be done without understanding. Like, let's go back to the tablecloth one for a second. You could say, okay, what's being displayed? And if you have a big enough database, like, well, what's more likely to be displayed, a table or a cloth? Cloth is more likely. Nobody displays a table on top of a cloth or a table under a cloth. So the idea is without reasoning or understanding, this could still be written in a way that chooses the right answer most of the time. And real language understanding, the way that you and I understand language, it's not binary very often. More often than not, we have a sentence and it paints this picture in our head of what it is that we're thinking about or deciding between. And it might be not just one thing or another thing, but it's a much more complex, nuanced, subtle evaluation than that. And the WC does not capture any of those other kinds of situations. And that's what most real language understanding is more nuanced, more subtle, not A or B. It's anything from A through Z and all the shades between. Now, going back away from the test, Turing test / WSC, and returning back to a definition. The Turing test, as a reminder, it tested something. Can something act like a human? Can it trick somebody into thinking that it's human? And then the WSC tested for intelligence as something that can look at these English sentences and pick the right one of two choices for the meaning of that, the correct meaning of that sentence, the correct interpretation of that sentence. And neither of those, while those might be, you could say those are tests, including all those other alternatives for the Turing test, none of them get at the heart of defining what intelligence actually is. So what I want to do is look at this alternate approach of coming up with a definition. So rather than just this weird test where you're like, well, we don't know how to define it, so let's just find a way to test it and see if it passes the test. And we'll say, hey, that's it, we found it. So there's this group, a couple computer scientists that came up with this alternate definition. And what their goal was to find a definition that, and this is not a test, it's a definition, but they wanted to get away from the human-centric nature of a definition and get down to something that kind of more captures the true essence of what intelligence is. So let's take a look at this. This is called the Legg and Hutter definition. And so this is named after Shane Legg and Marcus Hutter. And they're two AI researchers, but what they wanted to do, their desire, was they wanted to find this kind of broad, universal definition, a universal way to describe intelligence without tying it to human-centric, human-specific activities like chatting or reading or doing human things with human hands. They also didn't want to tie it to animals in general, so they want it to be open for machines, like AI entities, to do things. They also didn't want to tie it to machines, so they want it to be broad, kind of universally applicable as a way to describe intelligence. Now, they came up with this definition back in 2007 when they published this paper that was called A Collection of Definitions of Intelligence. And so they collected a whole bunch of these definitions, and then they presented their own that they thought had advantages over a lot of the other ones that they had found in their paper. So if you're interested, you can find their paper from 2007 and look at the other definitions they came across, look at why they decided to switch to their own definition. But the basic idea was they wanted something that was universal, not tied to humans, animals, or machines. And so here's what they came up with. It's actually pretty succinct, very simple, very straight to the point. But what they came up with was intelligence measures an agent's ability to achieve goals in a wide range of environments. And that's it. That's all that they came up with. But notice they started off with intelligence, and then they said their definition of it. So looking at that, let's go through the words. Agents. So intelligence measures an agent's ability to achieve goals in a wide range of environments. So agent, that is basically just something that acts in a system or within the world. Notice they didn't tie, that's not a human, it's not an animal, it's not a machine. It's just some entity of some sort. So intelligence is measuring something about this agent, and it's specifically an ability the agent has. Now, the next part of this we're going to look at is that next word, ability. So ability is a thing that it actually does. This is a action of what it can do. So we are measuring that entity's ability to do things. It's what it can actually do. Now, what is the ability that we're after? Achieving goals. So in other words, it's about getting things done, not passing a test to fool somebody, not necessarily answering questions about linguistic things related to sentences. It's about achieving some goal. In other words, this could fit with orcas. They're an agent. They have abilities and they can achieve goals, certain kinds of goals. They would do terribly on the WSC. They would not pass the Turing test. That does not mean that they're not intelligent, because they have abilities to achieve goals, and they can achieve goals in a range of environments. So that's the next part of this, that wide range of environments. In other words, they have to be able to succeed in something more than a very narrow use case or a narrow domain. In other words, we want to get away from the idea of language translator or just self-driving car or image generator. Oh, excuse me. So the idea here is it has to be adaptable. It has to, as the environment changes, this thing has to still be able to adapt and be able to achieve goals. And that collection of things there is actually a really succinct, nice definition of intelligence. Intelligence measures. So it's not just a yes or no. It's a measure, meaning it's a continuum. It measures an agent's ability to achieve goals in a wide range of environments. So the better it is able at achieving goals and the wider the range of environments, the higher the intelligence. So the more the abilities, the more the intelligence. The lower the abilities, the lower the intelligence. If something is completely not able to achieve goals, or it can only achieve goals but in the narrowest of environments, it's very low intelligence. Now, notice that under that definition, intelligence isn't really just knowing a lot, like we talked about earlier. It's not memorizing the dictionary. It's also not talking about things like the Turing test, where it's just chatting up people trying to fool them. And it's also not necessarily being really good at specific things, like a chess engine that's very good at chess. The definition kind of avoids all of that. It doesn't remember things or know a lot. In fact, there's nothing over here about memory at all. It's just an agent's ability to achieve goals in a wide range of environments. Memory might help you with that, but it's not part of the definition. So it's not knowing a lot. It's not chatting people up and fooling them, and it's not being really good at specific things. So what is it about? It's more about being able to figure out how to do what's necessary to achieve your goal, whatever that goal is, and be able to do so even when situations change or whatever the situation is that might arise. And based on that definition, we also notice that it has moved us away from that anthropocentric view of making it very human-centered. There's nothing in the definition about acting human or behaving like a human or passing a specific language test that looks at English language sentences and picks referents in them. The definition itself is about, can this entity, let's go back to it, can this entity, this agent, achieve goals? Who sets the goals? It or us or whoever, in that wide range of environments that could even potentially be dynamic and changing. Now, crystallizing all this back to the key capabilities that we talked about, at least that we hinted at earlier, and that is, intelligent systems all share some of these common traits. So perception, in other words, receiving some kind of input, and interpreting it in some way. Like us, like we look at the world with our eyes, we listen to things that are happening with our ears, we have a sense of smell and taste and touch. We're receiving that input, we're perceiving things. And then learning. Learning is partially remembering things, but adjusting our behavior based on that perceived input. In other words, when we are toddlers, we fall down a lot and we skin our knees and we learn how to walk better because of that. So it's that feedback loop that's based on perception, but then we also learn based on that perception. And then we have planning. And planning is basically choosing actions to achieve some goal, some desired result, but not choosing them randomly and just doing them. It's like thinking ahead or looking ahead, using reasoning, which is the next one. So drawing inferences from incomplete information. In other words, I have this information, but taking that cognitive leap to the next step and the next step, either as filling in a missing gap or as a planning, extrapolating, looking ahead. And then that last one there, that adaptation, which is very closely related to learning and planning and reasoning, a lot of learning there. But that's that robustness to a environment that's potentially changing. So, quick question here. Does a system that's intelligent require all of those or just one or two? In other words, could you have something that just perceives, and could you still consider that to be intelligent? Or could you have something that can, for example, plan without the ability to learn or without the ability to reason? And so that's a good question. Could you have just one of these, or could you have two? Or what's the minimum number of these things that you would need to have in order to have something that you would say was intelligent? Do you need all of them? And so that's a question I'm going to leave for you to ponder for right now. And now, next class, we're actually going to start digging into some stuff. So this is kind of the end of Unit 1, where we're thinking about and talking about intelligence at that very abstract level. I want to actually get in where we roll up our sleeves, start doing some stuff, start writing some code. So next class for Unit 2, we're going to review some programming topics. Maybe some of it will be new to you, but there'll be some review in there as well. And then we're going to start doing stuff with that and moving forward. And along those lines, what we're going to cover initially, what we're going to review is going to relate directly to AI and machine learning. It's going to be some Python review, but then we're very quickly going to start using it for stuff. We'll have some programming lab assignments coming up where we'll kind of wade into that slowly, but then we're going to build up over the next few classes. But be ready for Unit 2. And then in the meantime, in the chat or email or whatever, I want you to think about, how would you define intelligence? How do you think about it? Like, do you like that Legg and Hutter definition, or do you think there's more to it? So how do you define it? And there aren't really any necessarily right or wrong answers here. It's more like, when you think of the word intelligence, what do you think of? And hopefully today our discussion expanded beyond, intelligence, good at chess, intelligence, somebody reads a lot of books or has a big vocabulary, knows all the words in the dictionary, or it's a kind of an interesting word to get our mind around, because there's so many ways you can define it, but then you can think, well, but it doesn't quite work in this situation. I do like the Legg and Hutter definition, though, and it makes a lot of sense. It does take it away from humanness. It also, in addition to taking it away from being very human-centric. It kind of distills it down to the essence of what it means for something to be intelligent and adaptable. All right, so we will stop there. Next class, we'll dig into Unit 2. So that is the end of Unit 1. So there are some assignments to do. Hopefully you've been keeping up with the check-ins and looking at the assignment section on the course page. If not, make sure to look at that. Make sure to observe the due dates on everything on that. Make sure to keep up with that stuff as we go. That is important. So do that. And other than that, I will see you guys next time.